So today we're going to take a look at vertical and horizontal asymptotes. So you have some pockets that you are going to cut out, and let's see, why isn't this showing what I want you to show? Let me see if I can start this again. Hold on 1 minute. For some reason it wasn't coming up. Let's see if this is the right screen. There we go. So we're going to take a look at slant and horizontal asymptotes to start with today. We're going to look at a couple different things. So think of an asymptote as what's happening, as x gets really big. So like this one here, this asymptote, it runs along 0. And we've shifted those up and down. There also might be some slant ones where here's an asymptote and maybe your graph looks something like this, and it runs along the slant. So when you think about asymptotes, we're thinking as x gets really big. So x gets really big. Sorry about that. I had to pause that for a minute. So now what we're going to do is we're going to take a look at, you have all these tiny ones, and we're not going to worry about E8 for now, but we're going to look at these rational equations here and decide, where would that slant be? So if we look at E7 here, let's see, x squared and x squared. Those are the two numbers that as x gets big would give us the biggest values. That minus 6 plus 1, that's not really going to change a huge number. Neither is the minus x, even if it gets really large, because a million squared, if we just subtract a million, it's still a really large number. So I like to think of this one, this is a big number over a big number. So let's go through and see if we can find other big ones over big ones. So this is a big over big. If we look at E9, what's our biggest number? So we have x squared and an x squared, so that's the biggest. So this is another big over big. Let's see, not this one, because we have an x. If we look at this one, we got an x and x squared. Let's see, we got x and x squared, x cubed x squared, x squared. Oh, here's one, we got a 3x and 2x, so that's another one where we have those same powers there. Not E3, E4, E5. Let's see, we got now x squared is bigger than x, 2x squared is bigger than x. So we have those three. And the way you find it when there's two big numbers is you look at those coefficients, because when they get so large, x squared over x squared, it's going to go to about y equals 1, because it's the same thing, x squared and x squared. So if we look at this one, as it gets so large, we're only going to focus on these numbers. So x squared over x squared is 1, so this one would be 6 over 2, or at 3. Then when we look at this one, that plus 3 plus 2 doesn't matter, so as this gets really large, x over x is 1, so it's going to be y equals 3 over 2. So when you go back here, this would be horizontal equals some number. So this is when you have that, a big number over a big number, and it's that same big number. So if we take a look at the other ones here, let's take a look at, we're going to look at where we have a small over big. So this one would be a small over big, because 2 over a really large number. This was big over small. This one would be small over big, so we got another one here. This one would be small over big, x over x squared. Here's another x over x squared, 3x over x squared. And all of those are nice and easy. And when you think about a small over big, it's going to go to y equals 0. Like if you have 5 over a million, 10 over a million, it's really close to 0. So all of these are at your y equals 0s. So we could go back here, and we could put those in the pocket of small over big. And then this last one, slant, this is when you have a big over small. And to get your slant, sorry, this is kind of a mess here, you have to divide. So if we go back to our graphs here, We'll take a look at these bottom two here. You guys can totally see that this is big over small, 2x squared over x. And what I meant by you divide to find the slant, all you have to do is do that long division that we've been doing. So we have x minus 4. So inside we want x squared, so that's inside, so this has got to be x, negative 4x. But we want a total of positive x, so our next thing would be 5x. Let's see, so this would be plus 5. 5 times negative 4 is negative 20. So that would mean we have a remainder of 8, and we don't care about our remainder. Our slant is at x plus 5. Now when we look at this next one here, we have to do some division as well. So we have x plus 1. 2x squared needs to go on the inside. So we have that. So this has to be 2x. So down here has to be 2x. But inside we want negative 2x. So we have negative 4x. So this would be minus 4. Negative 4 times 1 is negative 4. So that means this would be negative 8, but we don't worry about the remainder. Our slant is at 2x minus 4. Now, the next thing that we're going to look at today is the steps for graphing these more complicated rational expressions. So the first one we're going to take a look at is the problem f of x equals x squared plus x minus 6 divided by 2x squared plus 5x minus 3. And here's the steps for graphing, and you can lift these up and put them underneath the flaps, but the first step is to factor and simplify. So I know that top part is x plus 3, x minus 2. Bottom one's a little bit complicated to factor because we have that coefficient of 2. So I could do 2x squared, 5x negative 3. So 2 times 3 is negative 6. So it multiplies to negative 6 and adds to 5. 6 and negative 1. So we have 6x and negative 1x. It's kind of a mess there. I apologize for that. So if we factor it, let's see, we'd have 2x, x plus 3 minus 1. So we can go back over here and we have x plus 3, 2x minus 1. And if we notice, it says simplify. Well, x plus 3 over x plus 3 is 1. So we're left with x minus 2 divided by 2x minus 1. Now our next step, some of our graphs might have holes. And there's a hole in the term that reduces out, if there's one. There's not always one. So in our case, x plus 3 reduced out, so there's a hole at x equals negative 3. We talked about yesterday finding the vertical asymptotes. We look in the denominator and where it equals 0. So if we have in our denominator 2x minus 1 equals 0, our asymptote is going to be at x equals 1/2. Slant. Well, let's see, what did we have again? We could look at our original or our simplified one. So we had x minus 2, or x minus 1. Was it plus 1? It was x minus 2. Sorry about that. So x minus 2 over 2x minus 1. So if we look here, they're both the x. So our coefficients, it would be at y equals 1/2. X-intercepts and y's. These are pretty easy. To find our x-intercept, we plug in 0 for y. So if we plug in 0 for y, 0 equals x minus 2 divided by 2x minus 1. And we clear the fractions, so we have 0 equals x minus 1. So our x-intercept is at 2, so it's the coordinate 2, 0. And then our y-intercept, we plug in 0 for x. So if we plug in 0 for x, y equals 2, oops, 0, oh dear, let's see, 0 minus 2, 2 times 0 minus 1. So negative 2 over negative 1 is 2, so it ends up at 0, 2.